Number 5. A remote-controlled toy car moves back and forth along a straight path so that its velocity at time t is given by the function v, measured in feet per second, and t is measured in seconds. In part A, we want to find the acceleration of the car at time t equals 1 second. That means we want to find v prime of 1. Now, that's going to be the derivative specifically at this using this part of our piecewise function. That means 3 times t to the third, 4 times t to the third, minus 24 times t squared, plus 32 times t to the first power. And that gives us -4. Now, notice it says, show the work and lead to your answer. They don't say anything about units, but they do give us a unit. So we will say feet per second per second, because this is a rate of change of this rate of change. Part B, is the car speeding up or slowing down at time t equals 1 second? Now we need to know the speed, the velocity, and the acceleration. So we already know that v prime of 1 equals -4. So to make our comparison, we need v of 1. So we're going to plug 1 into v. So we're still going to use that top part of our function. Times 1 cubed plus 16 times 1 squared. That gives us 9 feet per second. So since v of 1 is greater than 0, it's positive, and v prime of 1 is less than 0, therefore the toy is slowing down at t equals 1 second. We not only have to say why it's slowing down, we have to say why, because 1 is positive, 1 is negative, but we also have to include when it's happening, because at other times it could be speeding up or slowing down. So we have to focus on this one point at t equals 1. Part C, find the distance in feet that the car traveled over the time 0 to 4 seconds. So we're going to take the velocity and take the definite integral of that. And since it's from the entire time interval 0 to 4, we just need this one formula again. So we are going to have to take the antiderivative of this. So when we do, we have t to the 5th over 5 minus 2t to the 4th plus 16 over 3 t to the 3rd. Now, since this is non-calculator, they made it easy on us so that we only had to plug in 4. We don't have to really worry about 0. So if we focus here, 4 to the 5th over 5 minus 2 times 4 to the 4th plus 16 over 3 times 4 to the 3rd. Now here we have to know some of our powers of 2. So this is 1024 over 5. This is 512. And this is 1024 over 3. Now to make this work out a little nicely, what we're going to do is we're going to factor out 512. And that leaves us with 2/5 minus 1 plus 2/3. So inside it's going to be a little bit easier, and we'll just take what we get from the inside and multiply by 512. So we'll move that up here. So we'll give ourselves a common denominator. So we're going to multiply the first fraction, 3 on top and bottom, so 6 over 15 minus 15 over 15 plus 10 over 15. So we have 1 over 15. So we have 512 over 15. Definitely not divisible by 5. 1 plus 2 is 3 plus 5 is 8, not divisible by 3 either, so we can't simplify that. And since this is a distance, now they told us that it was a distance in feet, so whether you have or don't have the unit, that might be, I wouldn't worry too much about that point. But that is our distance of 512 over 15. Part D. Find the average velocity of the car over the time interval 6 to 12 seconds. So since we are given velocity and we're asked for average velocity, this is going to be 1 over 12 minus 6 times the integral of 6 to 12 v of t dt. Now here, since it's from the interval starting at 6 and ending at 12, we're going to be using this part of our piecewise function here. So 1 over 6, the integral from 6 to 12 of 10 cosine pi over 3 t minus 10 dt. So when we take our antiderivative, we're going to have 3 over pi times 10 sine pi over 3 t minus 10 t. Now here we have to plug in both 12 and 6. But let's remind ourselves, if we plug in 12 in for t, here we're going to have sine of pi over 3 times 12, which is sine of 4 pi, which is 0. And likewise, if we plug in pi over 3 times 6, that gives us sine of 2 pi, which is also 0. So the fact that we have a 3 over pi here, we're not going to really have to worry about that, because that's going to lead us to have a term of 0 anyway. So 1/6. And then we have 0 minus 120 minus 0 minus 60. So negative 120 plus 60. And we get an average of negative 10. Now this is an average velocity, feet per second.